And hello everyone, welcome back to the OpenFOAM C++ introduction. Okay, so in the last video, we sort of made an introduction into what pointers were, very briefly, a kind of crash course the way through. So pointers are basically the memory addresses of the values you are giving. These are the RAM addresses, and why they are important is because the way C++ plays around with vectors, or rather arrays, it's basically what they do is to deal with pointers. All right, it deals with pointers. So basically, that's what we have. Okay, so last time we were so-called trying to get this code working, and I was saying that you cannot you can only return one value. You can only return one value to this through this function. Okay, you can only return one value through this function. So there are a few things we need to kind of take note. Firstly, we cannot have we cannot have a sort of an array being the output of this of a function normally. So instead of having this add result 3,1, which is an array, I will just leave it as one singular value. So double add result will be that value. Okay, and let's try to G++ it. And what it says here is that I cannot convert a double star to double in return. Okay, so it's something to do with how we are putting out these results. So I guess, okay, what C++ is kind of expecting is a one singular value. All right, one singular value or double value. So I can't really give it anything else. So I can just if I were to give it this vector add result, likely it will just give you back the pointer. Okay, so let me try experimenting around this vector add result. Let me try and give out this vector add result and see what happens. Okay, still like the wrong type of data. You see, I cannot convert a double star 1 to double in return. So if I add one star here, let's see the error message. It says I cannot convert a double star to double in return. So you see that putting one star at the beginning kind of gives you it kind of takes away one of these dimensions of the vector or the array. Okay, so let me do it one more time. Let me give it 2 stars and let's see whether it works. Okay, so now it works. So actually whenever you have just a note, if you have a one-dimensional array, that means an array with one dimension, one number, so to speak. When you have an array with one number, you want to kind of get the pointer, you need to give it 1 star. If you have a two-dimensional array, you need to give it 2 stars, and so on and so forth. So okay, what I want to actually print out is this add result, and let's see what is the output. All right, let's run that. Let's run this YouTube folder. Okay, so I will get a number which is 2. 2 is actually the first let's see. Sorry. Yes. Excuse me there. The vector of the value 2, that is actually the first row and the first column of this the sum of these two vectors. So actually let's test it again. So I will just want to make the first the x value of the first vector to be 3, and the x value of the second vector to be 3. So you can see it will output the first value of the resultant vector. Okay, so it will actually return you the first value of this vector at result. So this is about the best we can do with the natural functions. All right, the way functions are run. When you do this, use this pointer thing, it can only return you one value. It cannot return you much more than that. This is about the best you can do using functions in this form. Anything else, you have to do some sort of tricks to kind of work around these limitations. So I mean, this is roughly what working with functions or working with arrays is like. It is not as straightforward as MATLAB. Alright, so there are some workarounds, and one of the workarounds is a very nice segue, a very nice lead-in into what I want to discuss next, and we want to talk about objects. So if you ever heard of a C++, you would have heard of this term called object-oriented programming. Okay, and we are going to go into that very shortly. Okay, but yeah. All right. So let's say for example, you found a magical solution, and there are solutions online on how to deal with arrays. Okay, for example, one working with arrays here, return array in a C++ function. There are some of these methods over here. One is to use the pointers, which was what I was discussing before. The second way is to use a structure. Okay, structure, I can sort of discuss it shortly, but these are very closely related to what something called classes, and that one we'll discuss it in a while. Okay, and then third is to use this method. Okay, but let's say you found a way to use pointers to actually return an array through a function. So that's one of the ways you can return an array. All right, but it's of course very tricky. There's a lot of working around, a lot of thinking that you need to do, and you need to declare something called a static variable. Okay, I'll quickly go through that, but I'm not going to go through this this particular way of working with arrays, because I mean, I want to kind of quickly go into structures and classes and objects, so that you can learn more about C++. But anyway, what's a static variable? Okay, so let's say you have this array here, or this function here, and you declare some variables in the function. For example, this thing called vector at result. Now the thing is, once you are done executing this function, vector at result will kind of disappear. It will no longer retain its values. That whole value of this vector at result, this array, it will be wiped from memory, and you will only have this return value being put out. And normally that is why it is hard to return an array through a function, is because the memory, once you're done with this once you're done with running this code, what C++ will do is it will just wipe out all the memory, and then you cannot return the you cannot push out. All right, you cannot push out the actual value of this array, because all the data has been deleted. And what you can do is to return the pointer, but then if you return a pointer here, which will as I was discussing before, a pointer will point you to the memory address of where you store the data. But for functions, once you finish executing your code, the data over here will be deleted. And even if you have the pointer here, right? Even if you have the pointer here that points you to the correct memory address, you'll find that there is nothing being stored in this memory address anymore. Okay, so how can we prevent this data from being deleted? Okay, so you would have to use this thing called static variables. And what a static variable is that basically after executing the function, when you have a static variable, it will not go through this deletion process I was talking about earlier, where after the function is executed, normally you delete all the variables there. But if you specify a variable as, for example, static, and then it will have the property such that, okay, once I'm done executing my function, it will not delete the data there, so that when I return the pointer, return the address of this particular array, what C++ will do is that, okay, now I can access all the data within this array, because I did not do this deletion process. So if I give you the pointer now, it should be able to retrieve all the values here. So that's basically that basically forces C++ to retain these values of these arrays. Okay, so it's not the best way of doing things, but it is certainly a way of working with arrays and returning arrays through a function, because you return the pointer, and the pointer will point you to where all the data is stored, and as long as you don't delete the data after you finish your function, then it should be fine. Okay, so alright, so let's say, so this is how the brief way of us working with arrays. It's kind of you need kind of a knowledge of what's how C++ actually reads data and reads arrays, and you need to know what a pointer is. And if you know that, then sure, you can work with arrays using this static variables. It will not be a problem. Okay, so you just look at this thing here. I'll give you this link in the description, but that's not how I want to work with arrays. Okay, anyway, so let's say you have your assortment of functions. Over here I have one or two functions, which is still fine, but in a program like OpenFOAM, you will have thousands and millions, I don't know if you get millions, but possibly thousands of functions. And do you want to then put them all in the same file? Likely not. Okay, you want to organize them in a particular manner. You want to group similar functions together so that it's nice and orderly, so that when you pass your code on to someone else and they need to read and edit it, it's actually doable, rather than you having to look through like one file and you can look for 1,000 of these functions. It is not very practical way of doing coding. So if you have like 1,000 functions and maybe 30 of them are similar, 30 of them pertain to vectors, you might want to group 30 of these functions into a group. Alright, and this group is actually known as a class. Alright, so a class is a way of grouping similar functions together. Alright, it groups okay, where do I, yeah, let me give you a way. Okay, hold on, yeah. Okay, I guess this W3 schools actually has it. Object-oriented programming. This is the basic things. Okay, so let's say, like I said, if you have functions of similar what do you call that? Okay, this I want to zoom into here. This thing called methods. If you have functions of similar, similar grouping, if they pertain to vectors, for example, you might want to group them together in a class. So if you take a look here, this thing is called a class. Okay, you can define a class, and then you have this thing called public, which I will explain perhaps later. All right, but here's the basic idea. All right, if you have functions that are similarly they work in similar ways and they are kind of related, you kind of want to use them together, you'll put them into the same class. Okay, so this is a way of grouping like functions together into a class, and under, let's say, this class over here, it says my class blah blah blah. You'll have a public here, and you will be able to put in multiple functions under this public access specifier, whatever that is, but don't worry, we'll get to that shortly. All right, so basically you can group similar functions together in the same class, and they're also known as methods according to this website. I'll put it in the description, but yeah, basically I can put both of these into a class. All right, and okay, let me close this. I can put both of these functions into a class, and actually doing using a class to deal with arrays, it makes it a lot easier to work with these arrays, because when you have a class, the C++ does not delete all of these information. For example, when you see this thing called vector add result or whatever, yeah, when you have these things, when you have such things, C++ does not delete these values until the end of the program. All right, especially if you define these values inside a class. Okay, so what the summary is: this classes are a way of grouping like functions together. For example, I have this thing called vector length and vector add, and this is kind of working. It sort of works. All right, it's not perfect. Definitely doesn't do what I originally intended it to do, but it sort of semi works. All right, but if I put them together in the class, it's a good way to organize them, and it's also a good way to make sure that all these variables do not get deleted after being executed. So the class not only gives you better organization, it gives you a better way of working with all these arrays. So that's what I probably want to explore a little bit more in the next video, and give you a live demonstration of how to work with classes and how you can actually categorize similar functions together, and of course work with vectors. Okay, so thanks for watching. I will see you guys again next time. Bye bye.